Okay, this video is over 5.7 roots and zeros. We have the fundamental theorem of algebra. A polynomial of n degree has exactly n roots. As we've been talking since 5.1, the degree of a function is equal to the number of solutions, and this includes repeated roots. Descartes' rule is a root that we'll talk about. And then you have the complex conjugates theorem, where any imaginary set of solutions come in groups of two. So the first problems are just solving. So depending on the question and depending on what you got going on, you need to make sure that you are solving it the best that you can. So this first one here is solved by factoring. Or you can solve a different way, find a solution that works, and I'll talk about that here on D. But the factors of -10 that add up to be -3 are -5 and 2. So x minus 5, x plus 2. Then you take each solution, x equals 5 and -2. Solve it out. The number of solutions you have based on your degree, you should have 2 solutions / roots. And then these roots are both 2 real rational. Coming down here to C, just so I don't have to move so much on my paper. This is a difference of cubes. So what cubed gets you x cubed? So if I take the value of x, or the variable of x, and cube it, I get x cubed. And then what value cubed gets you 8? The number that cubed gets 8 is 2. So this has a degree of 3, so this would be 3 zeros / solutions / roots. All the same answers, but I just want to make sure you understand that again. And then I'm going to take the factoring of a difference of cubes and go a minus b, a squared plus ab plus b squared. And the a's and the b's are just related to the spots of where the locations are. So a is your first little set of parentheses and b is your second set of parentheses. So this would be x minus 2, x squared plus 2x plus 4. There are no factors of 4 that add up to be 2, so what you have to do is on the first one, these all equal 0, I apologize. X minus 2 equals 0, and then you take x squared plus 2x plus 4 equal to 0. The first one's pretty easy, just x equals 0 equals 2. The second one you got to do the quadratic formula on, so a is 1, b is equal to 2, and c is equal to 4. And just do the quadratic formula. So -2 plus or minus the square root of 2 squared minus 4 times 1 times 4. All divisible by 2 times 1. So that gives me -2 plus or minus. In my calculator, I know it's going to be imaginary due to what it looks like. I'm going to type in 2 squared minus 4 times 1 times 4, and that's -12, so square root of -12 divisible by 2. -12 is a value that can be broken down into it's an irrational number because it's a square root, but it's imaginary. So this is actually going to be a complex number in the end. This is 4 and 3. So this would be -2 plus or minus 2i root 3, all divisible by 2. And then looking at that answer, this 2 in front of the plus minus and this 2 in the back are all divisible by 2. So it would actually be x equals -1 plus or minus I root 3. These are my 3 solutions. So I have 1 here, and then I have 2 here. So I have 1 real rational, and I have 2 imaginary / complex. So, working on this question here, B. B is a question where it's a difference of squares. So the perfect square that gives you 16 is 4 and 4. 81 is 9 and 9. To be negative, 1 has to be negative. So with that factoring, I know this would be 4x squared minus 9 and 4x squared plus 9 equals 0. You can go through instead and work with the factors of doing the x method. And if you did the x method, you would have 16x squared 16x squared, and then you would work with the factors of the x, I'm going to put it right here, of 16 times 81, which is 1296, negative. That add up to be 0 in the middle, and that's a negative 36 and 36. They're both divisible by 4, so that would get me right back to here. Now, I know this is going to have 4 solutions, 4 or roots, zeros. I don't care which word you use. And then what type are they? Looking at it, I can't just look at it and tell you, but I can kind of hypothesize that I'm probably going to have some imaginary going on because I have a difference of squares. Solve this. You have 4x squared equals 9. 4x squared equals negative 9. Divide by 4. X squared equals 9 divided by 4. X squared equals negative 9 divided by 4. Take the square root of both. So I'm going to do that here in a purple pen. And then if I wanted to, I would break them out as separate just due to time and due to what I'm working on. I just am going to do it as a whole and just look at it. So the square root of 9 is 3, so x equals plus or minus 3 over 2. X equals plus or minus 3 over 2 as well, but this has an I on it because it was negative. So those are my 2 solutions. This is 2 real rational. And I have 2 complex / imaginary. Now on D, I know we're kind of like all over the paper right now, and I apologize for that, but on D, I'm going to talk about what is really from like 5.8, and if we tell you to solve, so like you got to find an answer. So this isn't really factorable. So what you're going to do is we're going to have to find a solution. So what you do is you type it into your calculator. And once you've typed into your calculator, I'm going to go zoom 6 to get it back to a standard window. And with that standard window, I see there's a solution here at 1. So I know that x equals 1 is a solution. X equals 1 is a solution, which means x minus 1 is a factor because it's working backwards. So doing synthetic division, I have 1, negative 3, 9, negative 7. I'm going to do synthetic. That should be a 1. That's negative 2, negative 2, 7, 7, 0. Okay. So now my depressed is x squared minus 2x plus 7. And I'm like, okay, let's try solving this. This equals 0. And I look at it and I can't factor it. So now that I know that, I have one of my answers. I know I have to have 3 answers, so I have one of them. So I have 3 roots. I have 1 real rational. And then I need to find my other solutions. I can't factor this, so I have to do the quadratic formula. So a equals 1, b equals negative 2, c equals 7. So running the quadratic formula there. Negative times negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times 7, all divided by 2. So I'm going to get 2 plus or minus the square root of, and in my calculator, I'm just going to type it in. So I would have negative 2 squared minus 4 times 1 times 7, and that's negative 24 divisible by 2. So 24 breaks down to the squares of 4 and 6. 6 is not a perfect square, so I would have 2 plus or minus 2i root 6, all divisible by 2. So my answer would be x equals 1 plus or minus I root 6, and x equals 1. So that's the first part of the notes. The second part of the notes is Descartes and then finding all the zeros. And kind of what I just did was finding all the zeros. This part down here at the bottom of the notes, you don't need to worry about. So you can put a line through that. Descartes' rule is really cool, but what you're doing at is you're doing positive solutions, and these are real. then you have negative solutions that are real, and then you would have imaginary. And then if it's not imaginary or that, then you have zeros. Because 0, like x equals 0, is not it's a real number, but it's not a positive or a negative, and it is not imaginary. So then when you do that, that adds up to be the other values. So for example, Descartes' rule, the way it works out is what is your signs when you just look at the function. So positive solutions is just a positive x in the function. So when you do a positive x in the function, this is what you have. So positive, what are your signs? You have a positive, a negative, and a negative, okay? And what I'm going to do above on top is I'm going to write down if the exponent is odd or even. I'm going to explain why here in a second. So my exponent is odd, even, odd, and then none. Okay? There's no exponent. The reason for that is when you have an odd exponent and you plug in a negative x, so this is positive x, and this is negative x. Okay? If I plug in negative x in, I'm going to do this on a sticky note because I don't really have much room, because once you see it, it kind of starts to make more sense, but it just depends on what you see. So, if I take a negative x and I plug it in, try and move the mic, hold on. If I do negative x cubed minus 2 times negative x squared plus 2 times negative x minus 6, this becomes negative x cubed minus 2x squared minus 2x minus 6. And what that means is all I did was simplify. So what happens is when you plug a negative value of x in, all the exponents that were odd, so odd, even, odd, none, all the odd exponents, their signs change. So what happens is wherever you have an odd exponent, all you do is just change its sign. Sign, once again, is the value in front, the symbol in front of the term. Okay, so this would be odd, so it's now negative. Even stays the same. Odd changes. None definitely doesn't change because there's no x to plug in. So now what is this? Now what we do is we look at sign changes. So whenever there's a sign change, so you go from positive to negative to positive to negative, each time you change it, that's a sign change. So what we do is we just count them. I like to draw little loops. So 1, 2, 3. So that means I have 3 positive possible zeros. Negative, there are no sign changes, so there are no negative solutions, meaning I cannot have a value of x equals 1, or x equals 3, or, negative. X equals negative 1, negative 2, negative 7, any negative number would not be a solution. So if we apply that same process to the previous notes, here, my solutions, I had a positive answer and I have 2 imaginary. If I did the sign change of this, these sign changes actually match what this example is here, because it's a positive, negative, same thing. This says I have 3 positive answers and 0 negative answers. Well, I actually only had 1 positive answer. So going back to this, I have 2 imaginary answers, so what do I do? Well, with the Descartes rule, what happens is you always decrease your values of your possible solutions, of your positive or negative answers, by 2, because imaginaries comes in groups of 2. Since they come in groups of 2, if you have a number greater than 1, you got to count for each case. So I like to see the exact scenarios, which is a little bit more work, but I'm going to explain why here in a second. So I'm going to grab a different color pen. I'm going to grab this orange-ish color, and I'm going to show you what I do. What I do is I literally make a table. So it's positive, negative, imaginary, and then if I have zeros, okay? The numbers across, so each row of positive, negative, imaginary, and zeros have to add up to my degree. My degree is 3. So in the scenario of what I have here, I have 0, negative, solutions. So no matter what, I'm going to have 0 negative solutions, okay? And this is 0 as in, could have just wrote a z there now that I think about that. Z to me is integers, so I try not to do that. I have 3 possible positive answers. 3 plus 0 is 3, degrees 3, so I'm done. Now, I can decrease this by 2 because imaginaries come group of 2. So 3 minus 2 is 1. I can never get a negative answer because it said so. So if I use 1 here, I need to go to imaginary next. Imaginary get 2. 1 plus 2 is 3. Zeros, when x equals 0 is usually when you see something that you can factor out. It doesn't always happen, but it can happen. So I know on your homework, I want to say it was problem number 27, maybe 29. You have the values of when it might be 29, where your numbers don't ever add up to 5. And that's because there's an x squared that you can factor out, so you get a 0 twice. So, doing the next one, here we have, so we got positive x, so positive, negative. So this is even, so positive, positive, negative, negative, negative. So this is an even exponent, doesn't change. Odd changes, even doesn't, odd does, doesn't change at all. So how many sign errors do I have? So I have 1. So that means I have 1 positive answer for real zeros. I have 1, 2, 2. So now this one, now I know period 2, I told you to cross it out, don't worry about it. I'm just showing it so you can watch me walk through it again. So just bear with me on that. Might have been period 5 as well. So positive, negative, imaginary, and 0. How many answers can I have? Okay, so positive. No matter what, I gotta have 1. Okay, so that means I have 1 here. I should write that in green. I was also doing it in different colors. I'm not even paying attention to what I'm doing anymore. 1, 2. I can't have an imaginary as a single 1 because I got to get to 4 because it says a degree of 4. So I have 1, 2, 3. That means I have to have 1, 0. Now, once again, I have to have 1 positive, but I have a 2 here. So I got to subtract 2 from there, get 0. I got to have 2 imaginary. And then here, 1, 2, 3, I have another 0. So I know I'm going to have a solution at x equals 0. Which is really sweet, because then I can do synthetic with 0, which then it would get you a depressed polynomial. Also, with that, you can do other things. So, one last time, I'm going to do again, and then I'm going to solve some problems. I'm just actually going to show you how what you do when you says find all zeros and you can't factor it. And it's pretty quick. It's not that bad. So, let's do this and see if I can keep color coding today. Positive, negative. So I have positive, 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 negative. So there's 1 sign change. And then negative, so odd changes the sign. Even stays the same. Odd, change the sign here. So now I have 1, 2. So to do this, I am doing this on number 3 instead of C. I am so sorry. Well, this helps. This helps either way, because that will help me here in about 2 seconds. So, with that, positive, negative, imaginary, and 0. Okay. Positive, I have 1. So no matter what, I'm going to have 1 in positive. Negative, I have 2, which means 1, 2, 3, no, no. And now here, I have 1 positive, subtract 2 from 2 is 0, put it in the imaginary, and no zeros again. Did it on the wrong one, but the reason why this is so awesome to do, and I don't have to do it, it just gives me the mindset of when I have to use quadratic, because essentially what you're going to have to do in order to find all zeros is you need to go plug in your calculator. So if I take this, so I got a plus 9x squared plus 6x minus 16, and I hit graph, I can see I have answers. Now, the really cool thing about this is just seeing my graph, I can see that I have 1, 2, 3 solutions. Those 3 solutions are all positive and negative number, so I know this is my scenario. So it means I should not do a quadratic, which means things are going to function. Now, like I said, I jumped ahead on C, didn't mean to. I apologize on that, but since I'm already here, I'm going to start solving this problem because that's what you're going to have to do. So what you do is you pick one of those solutions. One of them. You don't have to pick all of them. I like to pick the positive one because it's already positive. Also, that's 1. And if I don't believe myself, I go second calc, and I can do the value, and I hit 1, enter, I get 0, or second calc, 0, and I go 0, 3, get my little number, and it's 1. So now that I know my answer is 1, I don't have any sign changes or any error messages that I have to do, which makes it nice. I do synthetic division. So 1 is an answer, x equals 1, from graph, which is what you're going to have to do on these two questions here to find all the zeros, unless you can factor it. If you can factor it, it's great, but if not, then you use your calculator to get one. And then what we do is we just do what we've always done. 1, 9, 6, negative 16. It better come out to be 0, because I know it's a solution. Bring down 1, 1, 10, 10, 16, 16, 0. So I now know I'm at x squared plus 10x plus 16 equals 0. The factoring of that gives me x plus 8, x minus 2 equals 0. Why do I know those two have to be positive? Because if I solve it, it's got to be negative because my graph told me so. Also, it's either one positive or not. Since I can factor it, it better be the scenario that's up above. And then x equals 8, negative 8, apologize, and negative 2. So doing that again, I'll just do positive negatives. It's just, I like doing it. Do you have to do it? Not unless I ask you to describe what type of roots, or state the possible number of positive negatives in this. Type of roots, to me, is doing this chart, and that's all you got to give me. So this is negative. So this would be plus, minus, plus, plus, minus. So even doesn't change, odd changes, even doesn't change, odd changes, doesn't change. So sign errors, or sign changes, excuse me, not sign errors. 1, 2, 3. So I have 3 or 1. So that's the two scenarios I got to do there. And then I have 1. Okay. So now on my chart, positive, negative, imaginary, I know I have to have 4 solutions, possible of zeros. Okay, so I have 3 or 1. I know I have to have 1 no matter what. Okay, 3 or 1, 0, 0, 1, 1, and 2. And then 0, 0. So it's either going to be 3 positive answers or 2 answers that are real with 1 positive, 1 negative, and then imaginary. So what I like to do, once again, go to our calculator, put it in the calculator. I'm just going to clear that out and go x to the 4th minus 6x cubed plus 9x squared plus 6x minus, and I want to say it was 16, nope, minus 10. So I hit graph, and I see funkiness. And I see I only cross the positive axis once, twice. So what I'm going to do is I'm going to factor this, and we're going to see what happens. Okay? So with this, get an answer. I know one of my answers is at negative 1, and I know one answer is at 1. Calculate it out, so second calc. I'm going to do it with 1 first, because like I said, I like to not have to do a bunch of math. So 1, that gives me 1, negative 6, 9, 6, negative 10, 4, 3, 2, 1, 0. Match my numbers, double check, draw a line. Bring this down, 1, 1, negative 5, 4, 4, 10, 10, 0. So now I'm at x cubed minus 5x squared plus 4x plus 10. Now I could do a few different things. I could factor by grouping, and I see that it would work, which is what I'm going to do. Or you could do synthetic again with -1. Your choice. So you could do synthetic again because -1 is an answer, and run through with the numbers here of 1, -5, 4, and 10, and get to something that you can factor. Or you could factor by grouping. Either way, you'll still get the same answer. I'm just going to show it with factor by grouping here. So this factors down to x squared times x minus 5 plus 2 times -2. Nope, can't factor by grouping. Yes, I can. What can I do? Did I do it right? I did the math right. Oh, I don't get to factor by grouping? This makes me sad. So +2, x, well, technically yes, x, no, because that's where I get my monkeys, plus 5. So I can't factor by grouping. Very sad. So that didn't work. Since I can't factor by grouping, even though it looks like I can because I read that as a plus and not a minus and my eyes don't work today, we're going to do synthetic again. -1, -6, 6, 10, -10, 0. Alright, so now we're here at this. So we got x squared minus 6x plus 10. There are no factors of 10 that add up to be -6, so we can do quadratic formula. So negative times a -6 plus or minus the square root of -6 squared minus 4 times 1 times 10, all divisible by 2. So you get 6 plus or minus the square root of, second quit, this is why I couldn't factor by grouping. Ugh, makes me mad. 36 minus, I want to say it's 40. It's 40. -4, all divisible by 2. 6 plus or minus, so this becomes 6 plus or minus 2i divisible by 2, which gives me 3 plus or minus I. So my solutions, when it says find all the solutions, I'm going to write it back underneath over here, underneath my graph. You can't see that, I apologize. But I'm going to write it over there, and I'm going to go x equals 1, -1, 3 plus or minus I. Now, if it asks for all the factors, because we like to do that, taking this, okay, so solutions, so factors, all the factors, I'm going to write those out in a different color. I don't have enough colors to do all this today. I am running out of colors. I'm going to write it out in a different color. I'm going to write out x minus 1, x plus 1, and then x squared minus 6x plus 10. These are my factors. Now, where do they come from? So, the x minus 1 comes from here. So this is first, second, and then last. All right. There's 5.7, all of it, in a nutshell. The assignment is for tonight, so day 1, day 2, is 17 through 51 odd. Monday, day 3, is worksheet. Okay? So those who are gone and got work ahead of time, day 1, day 2 is 17 through 51 odd. That's on the calendar, and then Monday will be, instead of it being a work day, we're switching the work day and the worksheet on Monday. Enjoy your weekend.